he is going to give components or vector form. If you give components directly, we can go for vector form. And what we have to find is magnitude of a vector and its direction. We have to find it. That is, he is going to give r bar is equal to rx I cap plus ry j cap. So we have to calculate the magnitude of this vector and also its direction. See, both x coordinate and y coordinate are positive. That's why you can take this vector in first quadrant. So this value is equal to rx, this value is equal to ry. Now we have to calculate the magnitude of r bar, that is equal to r. From this right angle triangle, what you can write? R is equal to rx square, r square is equal to rx square plus ry square. So r is equal to under root of rx square plus ry square, that is under root of x component square plus y component square. This is the magnitude of a vector. And how to calculate the direction? The angle made by the vector with x axis. So tan theta is equal to ry by rx. Y component by x component gives you angle made by the vector with x axis. Suppose if we take this as alpha, so this is ry, this is rx. So tan alpha is equal to rx by ry, in the denominator ry. So you will be getting angle made by this vector with y axis. So your choice, no need to remember these formulas, and there is no restriction that you have to follow this method only. And let me go for an example. See here, the vector a bar is equal to minus root 3 I cap plus j cap. Now let us calculate the magnitude of a vector, and the second one is direction of this vector. How to calculate the magnitude? Very simple. Magnitude of a vector is equal to under root of x component square plus y component square. So magnitude of A is equal to under root of x component. So minus root 3 whole square plus 1 square. What do you get? 3 plus 1, that is 4. Root 4 is equal to 2 units. Magnitude of a vector will never be negative, keep in mind. Even though you are having components negative, by calculating magnitude you will be getting positive only. And magnitude is over, first question is over. And what is the second question? Second question, we have to go for direction. So the teachers follow different methods, and I am following my own method. See, this is x axis, y axis, and x component you are having negative, y component is positive. That's why this vector you can take in second quadrant, rough diagram, and the x coordinate is root 3, because once I have decided that the vector is in which quadrant, no need to go for any sign, and y coordinate is 1. Suppose if you take this is alpha, so tan alpha is equal to, you can write 1 by root 3, so alpha is equal to 30 degrees. So if you start from positive x axis, this 30 degrees is clockwise with negative x axis. Sorry, it is negative x axis. But direction means, by convention we have to give the anti-clockwise angle with the positive x axis only. If it is 30 degrees, this will be 150 degrees. So direction is, as per as the direction is concerned, 150 degrees anti-clockwise with positive x-axis, anti-clockwise with the positive x-axis. And in options, sometimes you don't find this 30 degrees clockwise with the negative x-axis, you don't find 150 degrees anti-clockwise with positive x-axis, you can find this clockwise angle with the negative y-axis. How to calculate clockwise angle with the negative y-axis? You start from here and move clockwise. So this will be 90 plus 30. So 120 degrees clockwise angle with the negative y-axis, or this 90 plus 90, 180, 180 plus 60, 240, 240 degrees anti-clockwise angle with the negative y-axis, or with the positive x-axis. What is clockwise angle? This is, so 90 plus 90 plus 30 degrees, so 210 degrees clockwise angle with positive x-axis, or with the positive axis. Let us see, with the positive axis, this is anti-clockwise angle, that is 60 degrees, and this is clockwise angle, so 90 plus 90 plus 90, so 270 plus 30, 300 degrees clockwise angle with the positive y-axis. If we don't mention with which axis and whether we have to calculate clockwise angle or anti-clockwise angle, if we don't mention, by convention we have to give this answer. If he mentions, then by calculating one angle we can go for all other angles. It is very easy for us to calculate. And the same problem somebody tried to do like this. So in the previous example, tan alpha is equal to, you have seen ry by rx, now y component by x component, that is 1 by minus root 3. Why don't we directly do, because alpha is anti-clockwise angle made by the vector with the positive x-axis, so directly we can go for it. Yes, you can go for it. Minus 1 by root 3, that is tan alpha minus 1 by root 3. Minus 1 by root 3 is, from the table we can write, let us see, alpha is equal to, suppose if it is 150 degrees, so 90 plus tan alpha, tan 90 plus 60, tan 90 plus 60, or 180 minus 30, so minus tan 30, minus 1 by root 3. Yes, alpha value is 150 degrees, or 150 degrees, or even 300 also possible. See 300, how it is possible? Let us see. Tan 300, how much? Tan 360 minus 60, so minus tan 60, so minus, it is 330. 360 minus 30, so it is minus tan 30. Minus tan 30 means minus 1 by root 3 only. So my question is, here you will get one confusion. Yes, directly y component by x component you can do, you will be getting minus 1 by root 3. Now two values of alpha possible, anti-clockwise angle with positive x-axis, whether is it 150 degrees or 330 degrees, again you have to decide. This vector is in second quadrant, that's why 150 degrees is correct answer, not 300. If it is in fourth quadrant, like root 3 I cap minus j cap, then you have to prefer this 330 degrees.